Forget everything you think you know about the ocean. Forget the serene sunsets, the playful waves, and the simple, static image of a vast blue expanse. That is just the surface, a deceptive skin. Beneath that shimmering veneer lies the most powerful and complex machine on our planet. A planetary-scale engine with a heart that beats with the tides and a nervous system of colossal currents. This is a machine that dictates our weather, sculpts our coastlines, holds the coded secrets of our past, and will ultimately determine the fate of our future. According to physicist and oceanographer Helen Zersky, it is the blue machine, the very engine that powers Earth. And today, we are going to look under the hood to trace the gears and plumbing of this immense living system. We're diving headfirst into the breathtakingly intricate inner workings of our world's oceans. This is not just a story about fish and coral. It is a story about the fundamental physics, chemistry, and biology that make life on this planet possible. We will explore the profound questions that reveal the ocean's true nature. How does the simple, silent rotation of our planet choreograph ocean currents that span thousands of miles and carry the thermal energy of thousands of nuclear power plants? What is the secret behind the ocean's pervasive saltiness? And how does this single property drive a global circulation system that acts as Earth's thermostat? We will join scientists on the front lines of discovery, embarking on a 1970s oil rig turned research vessel, the Joides Resolution, as it drills deep into the seabed off the coast of Portugal, hunting for climate time capsules buried for millions of years. And we will listen in, quite literally, as marine biologists attempt to resurrect dying coral reefs using a symphony of sound. This is the story of the ocean as you have never heard it before, a living, breathing, dynamic system that connects us all. So let's begin with the most basic, yet most profound property of the sea, its saltiness. We take it for granted, but that salt is the master key to the entire engine. For billions of years, rivers have been tireless couriers, performing a slow, patient act of geologic alchemy. They erode rocks on land, dissolving minerals, and carrying these salts on a one-way trip to the sea. As pure water evaporates from the ocean's surface to form clouds, the salt is left behind, becoming more and more concentrated over eons. This process is supercharged by one of the most alien environments on Earth, hydrothermal vents on the ocean floor. These are volcanic fissures, black smokers spewing out a cocktail of superheated, mineral-rich water from deep within the Earth's crust, looking like hellish underwater cathedrals. But this salt does more than just season the water. It fundamentally rewrites its physics. Salty water is denser, heavier than fresh water. This simple fact, combined with temperature, creates a layered ocean, a stratification of vast water masses with different properties, all constantly in motion, seeking a delicate equilibrium. Cold, salty water is the densest of all, and it has one destiny: to sink. This simple act of sinking, happening on an immense scale in just a few key locations like the North Atlantic and Antarctica's Weddell Sea, is the starting pistol for a race that lasts 1,000 years. It kicks off the Great Ocean Conveyor Belt, a massive, globe-spanning current that acts as the planet's circulatory system. This is the true power of the blue machine. It is a slow, cold river of lifeblood, a 1,000-year-long journey through the crushing blackness of the abyss, transporting heat from the overflowing furnace of the equator to the freezing poles, moderating our climate and making vast regions of the planet habitable. Without it, the tropics would become an uninhabitable inferno, and the higher latitudes would be locked in a permanent, unforgiving deep freeze. But this engine has another critical, invisible component: the constant, unwavering spin of the Earth itself. Imagine you are standing on a giant spinning merry-go-round. If you try to roll a ball straight to a friend across from you, it will not travel in a straight line. From your perspective, it will appear to curve away. The Earth is that merry-go-round, spinning at over 1,000 miles per hour at the equator. Every drop of water, every gust of wind is caught in this constant planetary waltz, a phenomenon called the Coriolis effect. In the northern hemisphere, it deflects moving objects to the right. In the southern hemisphere, to the left. This cosmic spin is what organizes the ocean's surface currents into massive, stable, circular patterns called gyres. These are not gentle eddies. They are continent-sized whirlpools that churn the ocean, driving weather systems and entire ecosystems. They are the reason Western Europe's climate is so much milder than Canada's at the same latitude. The Gulf Stream, a powerful river of warm water within the Atlantic, is a product of this system, carrying a colossal amount of tropical heat northward, a life-giving gift from the ocean's engine. It is a mind-bogglingly complex and delicate system, is it not? If you are finding this deep dive into our planet's engine fascinating, do us a favor and hit that like button. It tells us you want more content that explores the foundational science that shapes our world. This powerful engine, however, is also the cradle of life, and its largest, most diverse ecosystem is now facing unprecedented threats. Nowhere is this more tragically visible than in our world's coral reefs. Picture a healthy reef. It is a bustling, vibrant metropolis of the sea, an explosion of color, shape, and movement. But more than that, it is a cacophony of sound. The constant, sizzling crackle of snapping shrimp, the grunts, clicks, and chirps of fish communicating, the scraping sound of parrotfish munching on algae. This is the soundtrack of a thriving community. Inside each tiny coral animal, or polyp, live microscopic algae called zooxanthellae. In a beautiful symbiotic partnership, the algae photosynthesize, providing the coral with up to 90% of its food, and in return, the coral provides a safe home. This partnership paints the reefs in their spectacular colors. Now, picture a bleached reef. When the water gets too warm, the corals become stressed, and in a desperate act of self-preservation, they evict their tiny algal tenants. This is bleaching. The vibrant colors vanish, revealing the stark white skeleton beneath. The reef becomes a ghostly, silent graveyard. The fish have fled. The shrimp are gone. The only sound is the mournful whisper of the current passing over the dead. This profound silence is what marine biologist Tim Lamont is trying to combat. His work is based on a beautifully simple but radical idea. What if you could lure life back to these barren reefs by tricking it into thinking the reef was still healthy? Lamont and his team travel to these desolate underwater landscapes and install underwater speakers. Then, for weeks on end, they play the sounds of life. They play the symphony they recorded on healthy, vibrant reefs. The results are astonishing. Young fish and coral larvae, drifting aimlessly on the currents, hear this familiar, reassuring noise. It is a beacon of hope in the empty ocean, a sonic signpost signaling a safe place to settle and grow. They are drawn to the sound, choosing to make their home on the acoustically enhanced, once-dead reef. It is a form of acoustic restoration, an attempt to jumpstart the ecosystem's recovery by rebuilding its soundscape first. It is a testament to both the fragility of these ecosystems and the incredible ingenuity of the scientists fighting to save them. The ocean not only holds the key to restoring life, but also to understanding its past, which in turn could help us navigate our climate-changed future. To find these answers, we must travel to a place few will ever see, the deep ocean floor. Our chariot is the Joids Resolution, a vessel that looks like it sailed right out of a 1970s movie. It is not a sleek research ship, but a converted oil rig, a 470-foot-long industrial behemoth with a giant derrick towering nearly 200 feet above the water. For decades, this unique floating laboratory has been home to rotating teams of international paleoceanographers, climate detectives, on a mission to read the Earth's diary. Their method is brute force but incredibly precise. They drill. They lower thousands of feet of pipe through the immense, crushing pressure of the deep ocean and drill into the soft sediment below. The drill bit grinds through layers of ooze and clay, each centimeter representing centuries of history. What comes back up is a core sample, a long tube of mud that might look unremarkable to the untrained eye. But to these scientists, it is a time capsule of unparalleled value. Each layer of sediment corresponds to a different period in Earth's history, going back millions of years. Trapped within these layers are the microscopic calcium carbonate shells of tiny organisms called foraminifera. These ancient creatures are the true prize. When they were alive, the chemical composition of their intricate shells perfectly recorded the temperature and chemistry of the water they lived in. They are perfect tiny thermometers and archives of the ancient sea. By analyzing these shells, scientists can reconstruct the climate of the past with incredible precision. On a recent expedition off the coast of Portugal, scientists were hunting for clues from a time when atmospheric carbon dioxide levels were similar to what they are today. They are essentially looking for an instruction manual, an ancient blueprint buried deep beneath the waves, on how the Earth system responds to a warmer world. They are asking the Earth's own memory. What happens when the planet's thermostat is turned up this high? By understanding how the oceans reacted in the past, how currents shifted, how sea levels rose, how life adapted or perished, we can create better, more accurate models to predict what lies ahead for us. The answers to our future might literally be buried at the bottom of the sea. To make sure you do not miss our next exploration into the incredible stories of science and discovery, be sure to subscribe and turn on notifications. From the salt that drives its deepest currents, to the planet's spin that shapes its surface, from the sound that signals life, to the sediments that record its epic history, the ocean is a single, interconnected system. It is, as Helen Chursky so eloquently describes, one great blue machine. It is not a separate realm that we visit on vacation. It is inextricably linked to our existence. The oxygen in every other breath you take is a gift from photosynthesizing phytoplankton in the sunlit upper ocean. The weather outside your window, the rain that falls on your crops, is being influenced by heat stored and transported by ocean currents thousands of miles away. The salmon on your plate, the shipping container that brought you your phone, the very stability of the global economy, all are beholden to the whims and health of this blue machine. We are all passengers on this planet, utterly dependent on an engine we are only just beginning to truly understand. So the next time you stand at the edge of the water, listen to the timeless rhythm of the waves and feel the salty sea spray on your face. Remember what you are truly witnessing. You are not just looking at the ocean. You are looking at the intricate, powerful, and mysterious blue machine that made your life and all life on Earth